Okay, welcome back for the finale today. How are you doing? So you're hearing me okay?
Yes.
Yes.
Good, good. Thank you. All right, as I had said earlier, we are in the throes of the second chapter, which is logic. We are trying to go through both of all of this in 2 days. So, and then realize then we're going to have another test on that chapter on Thursday. And that's pretty much the way it is because we got 6 weeks and we essentially got 6 tests, counting the 2 exams. So it's got to be one a week. Not much way around that. I do have one, but it's going to be after midterm where it's kind of the 5th of my chapter tests. It's just like a partial and it'll be open for a few days. Like you can do it spare time, that kind of thing. It won't be proctored, but that's just one of those just to buy us a little bit of time, because if we're using a day for the test, then it kind of takes away from the material in a way that or it takes away from the time, so we don't have as much time to cover the material. So anybody got any questions before we get started? All right. So just don't get caught off guard with that, because like I said, we're dealing with a test a week, test or exam every week. So another one here coming out Thursday on chapter 2. All right, well, let's get back over to the notes here, and then we'll look at things in a little bit more depth here. Also, I'll take advantage of the textbook. I should have opened it up before. Let's see if I can get back over there, because that's got some good problems in it.
Right.
Let's see. Let's just stay in that one. And I'm going to go into Alex directly. Well, that's not going to work. I don't know what happened to my. Oh, well. Go this way then. Oh, it's blocking the pop-ups now. That's strange. I don't know why it started doing that. All right, there we go. I just want to have the book available.
All right. Let's see. 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 Let's see.
Okay, so as I said, I just wanted to reiterate because I know there's people still coming in. We're doing with another test on chapter, the logic chapter. So it'll be on Thursday, one test a week, basically, test or exam. Next Thursday, not this coming Thursday, but the next one will be the midterm exam. And we got to go over a little bit of extra stuff here before midterm. So. Okay. So make sure for next week for that exam, I think most people had the AutoLock working because you took that verification thing, but just realize we got to have that on AutoLock. It's got to be proctored on that system. All right, let's go back over here. All right. So to start out the chapter logic, the first thing we talk about are these things called statements and logical connectives. If we're dealing with a statement, we're just dealing with a sentence that gets across one idea. It's not a question, it's not a command. It's got to be something. It's got to be a statement, not a question or command. It does not matter if it's true. So let's see what we can find in here. Some other examples, since I already took you through those. So here's what we got. So in the English language, we got several types of things. You got factual statements. In other words, you have to pass the bar exam to practice law. You got commands, get out of my face, opinions, chocolate cake with ice cream, icing is the best dessert ever, questions, sup with you, exclamations, holy cow. Well, as far as logic is concerned, it's got to be a factual statement. That does not mean that it has to be factually true. It just means that it has to bring together certain elements of knowledge and write them in a statement form, not as a command, not as a question, not as an exclamation, and even an opinion is not going to help us. Now, the one thing that we can do to determine if something is a statement is, can it be either true or false? It does not matter if it's true or false. Like my example that we used in the early part of the earlier class about New Orleans is the capital of Florida. That's obviously a false statement because we know about that. That's the reason I used it. But that's what determines that it is a statement, because it's a false one. It's not an opinion. It's a false statement. Opinions and false statements are different. See how they come up with this chocolate cake with cream cheese icing is the best dessert ever. Well, again, that's an opinion thing. We could probably rearrange that and make it into a factual statement. But if it has to do with one individual, that's where we start getting into that area that we got to be concerned about. We want it to be something we can factually check. You can read this if you want to be further enlightened, but let's look at some of these. So look at number at A. This has to do with global warming, because it says most scientists agree that global warming is a threat to the environment. Now, that does not mean that it's necessarily a true statement. But what we've said is that most scientists agree that global warming is a threat to the environment. That's all that it's saying. It's making that statement. And when we say most, that generally means more than 50%. Here's a question. Is that your laptop? If you got a question mark on it, that's a dead giveaway. It's not a statement. Man, that hurts. A command. Now, believe it or not, D is a mathematical statement. It's saying 432 plus 8 divided by 1.3 is equal to the square root of 115,000. Now, with this, it's actually making a claim about something factual. And I don't know if it's true or false, but I could probably determine whether it's true or false. We don't really need to, but you can kind of see here if we use the calculator. So we do this part first, 8, because you do order of operations. We don't really need to know about that in this class here, but so plus the 432. So we come out with 438.15. Well, let's see if it's more or less the same as 115,000. Whoops. Yeah, Oops, I didn't put the square root in it. Obviously, it's not the same because that one would end up being 30 something. This one is 3 something. So that's false, but it is true. It is a statement. It's making a factual claim. This book is about database management. Now, we don't know what the book is, but we could, if someone is presenting a book, we could go and look at it and see that's what it is to find out whether it's true or false. So watching reality shows turns your brain to mush. Well, this is not a statement because it's basically giving an opinion, and it's also given a kind of a murky thing because it's a figurative language there, right? Figuratively, your brain is turning to mush by this statement, which watching anything is not going to turn your brain to mush. Something is going to change your brain to mush. I don't know. Getting like bitten by a zombie might do it, but the point I'm making is it's using a figurative kind of claim. That's not something that we can judge scientifically to be true or false. So let's just see what we got here. All right. What about this first one? Is that a statement? Is that a statement? Those pants rot? Nah. 8 minus 12? Well, it's making the claim. And it doesn't matter whether it's true or false, but in this case, it's false because that would be 4, but that is a statement. Give me a bottle of anything to go. I'm sorry, give me a bottle of anything and a glazed donut to go. Okay, again, that's a command. Cat can send picture messages with her cell phone. Well, that's something we could determine to be true or false. I doubt that cat can do that, but I got a cat that comes close. When does the party start? Again, that's a question. So history is interesting. Okay, that's one of those things that's kind of a nebulous kind of statement. So we're going to say it's false. Because again, it's an opinion. So simple statements versus compound statement. A simple statement is just one of the types that we've just looked at. But we can take statements and bind them together with and, or, the conditional if then and the biconditional if and only if, and make compound statements. So these are simple ones. Your jeans are torn. My dorm room has a pile of dirty socks in it. Daytona Beach is in Florida. But if we tie two of them together with an and, an or, an if then, if and only if, then we got a compound statement. So what they give us here is taking chemistry this semester and I'm going to get an A. It's a compound statement because of and. Here's one statement, and there's the other statement. So here's some other compound statements. John studied for 5 hours and he got an A. And so this statement is a conjunction. Conjunction. I'm going to pass this class, or I'm going to change my major. If I get 80% of the questions on the SAT right, then I will get into law school. That's an if, then. That's a conditional. And biconditional is when you got that if and only if. There's a couple other ways to put it, but as far as you're concerned, it'll always be if and only if. We will win the game if and only if we score more points than the other team. And again, you can kind of see with the biconditional that those teams are essentially equivalent. The team that scores more points than the other is the winner. So sometimes then will be omitted. So you just got to realize that it's a conditional, because usually what they'll do is just instead of say if it snows, then I will go skiing. Kids, more likely to see it as if it snows, I'll go skiing. It's just that it's got the conditional promise in it. Let's see what we can do here. My jacket is warm. My jacket is both warm and light. This is an informative website on STIs. If it doesn't rain tomorrow, I'm going swimming. I'm sorry, windsurfing. I'm going to eat at Taco Bell or Wendy's today. Yesterday was the deadline to withdraw from the class. All right. So let's see here. This one right here is simple. And that's actually today is the, I probably should tell you that. Today is the day to withdraw from the class. I don't think anybody needs to do that, but if you withdraw before 1 o'clock, you don't the class doesn't end up on your transcript. After this, you're in it for a grade. So this right here is compound. All right. This is a simple one. So again, this was simple. All right. But what about this one? I'm going to eat at Taco Bell or Wendy's today. If you write it like this, TB, or I am going to eat at Wendy's, then if you rewrite it like that, then you can clearly see that it's compound. So it's making two separate ones. Then this one right here, it's kind of hard to understand the way it's written, but my jacket is both warm and light. So again, you could write it as my jacket is warm and my jacket is light. So with that, then we could easily call it compound. And I'll just write a little C there for compound. So this is what I mentioned earlier about the quantified statements. Quantified statement is all, none, some. This one kind of some and at least one are the same thing. So if you see at least one, then that's the same thing as some. So every student taking philosophy this semester will pass. So it's quantified, not just saying a student taking philosophy this semester will pass. It's claiming every student. All right. No nursing student is also majoring in criminal justice. Again, they don't have to be true or false, but they are making that claim by now using a quantifier. And the some people who are Miami Hurricane fans are also Miami Dolphin fans. And like I said, there is at least one is the same as some. So the negation of a statement is just basically, as I said before, you're either going to negate it grammatically. So if Auburn will win Saturday is the statement, then the negation would be Auburn will not win Saturday. I took a shower today. I did not take a shower today. My car is clean. Well, my car is not clean. It's the negation. You're stating the opposite of it. So this is that same little thing I got over here that I showed you about. All, the negation is some, and some negates is all. I'm sorry, all negates is some or not. Some negates is none. So just going back and forth on here gives you the negation. So you see here, all, the negation is some or not. So if the example is all of my meals are low in fat, then the negation will some are not. Some of my meals are not low fat. So the some majors require 5 years of study. The negation is there are no. So the negation of some is none. There are no majors that require 5 years of study. Some do not. Well, we're going to go back to all. See again, here's the back and forth. All, the negation is some or not. Some are not, the negation is all. And then here, these are two. So these are the same, and these are essentially the same when you go back and forth as far as the negation. Some people don't go to football games. The negation is all go to the football game, or everyone goes to the football game. So if we've got a none, then the negation of none is some or at least one. No airlines include checked bags for free. At least one airline allows a checked bag for free. Okay. I'm just going to pop the answer on here, let you see that. Like I said, this is not a major thing in for us. So all the negation is some or not. So all smartphones have cameras. Well, the negation would be some smartphones don't have cameras. No women can win the lottery. Well, the opposite is some women can win the lottery. Some professors have PhDs. The negation is none do. Again, we're not worried about the truth or the falsity of it. Someone in this class will get an A. The negation is no one in this class will get an A. So that's just the same little thing here being carried out. So all the negation of some or not is all. The negation of some is none. The negation of none is some are. All right, we're going to get to doing some truth tables. This is just a review of those symbols. So and, which is the basic. So in the set theory, these all have, or both of those up there have. So this is the that symbol. That's what we used over there. These don't really have a counterpart. This is just basically equal. And then this is the only way to really put this one is just when you're dealing with set theory, it's got to be one set completely contained within another. Like I said, there's no really I could put this in there. Proper subset. You know what? I can rule out the proper subset symbol. So those are the things that essentially mean the same thing as what we're doing in the logic. The one that looks like an A without the line through it, that's the and. The one that looks like the V, same direction as the U, is the or. The arrow always goes just left to right. That's the if then, the conditional. The if and only if is the double arrow. All right, let's see if we can do some translation here. All right, so let P represent the statement, I will buy a Coke, and Q represent the statement, I will buy some popcorn. Write each statement in symbols. So for here, It's P and Q. That's the symbolic. This one right here, I will not buy a Coke, so that's going to be not Q. If I buy some popcorn, then I will buy a Coke. So then that's Q. If Q, then P. I will not buy a Coke, and I will buy some popcorn. Not Coke is not P, and Q. So translating into symbols, it's important stuff we got to do, especially for tomorrow when we do the logical arguments to find out if they're valid. We do need to write them symbolically.
So for B, don't it's supposed to be the squiggly line in the P because it's not Coke?
Oh, thank you. Look at that. Y'all catching on to me and my craziness. You are right, because P is Coke. You got to watch this too, like I said, is they put the P over here, and right over here, the Q comes after. So that's what I was looking at. So glad to have a mind in here that's sharp. All right. So translating from symbols to words now. So P is my dog is a golden retriever, and Q is my dog is fuzzy. So on this one, it's not P, so that's my dog is not a golden. This is P or Q. So my dog is a golden or my dog is fuzzy. Or. If my dog is not a, I'm just going to abbreviate golden retriever, then my dog is fuzzy. This one is just the if and only if. My dog is fuzzy if and only if my dog is a golden retriever. And then here, and my dog is a golden retriever, and my dog is fuzzy. So both ways. If you got the statements defined for you, and then you've got symbolic statements, then you can write them. And if you've got the statements and then you define them, then you can write them symbolically. It's just two sides of the same coin. All right. So let's now get to the truth tables. The truth tables is the heart of this chapter because truth tables is the method by which we can boil a symbolic statement down to one column of T's and F's that represent it. We can also tell if an argument is valid by creating a truth table for it. So these are the ones that I have, as I had showed you. See, that's my same thing of what they've got. See, they're going through, there's the negation, then they're doing the conjunction. I've just got them all in that one spot in the notes. So see that TFFF, same as mine. And look at that, they even stole my summary. They never used to do that until I started doing it. This conjunction P and Q is only true when both P and Q are true. If they're not both true, it's false. If you got one T and one F, you got one F and one T, it's false. Or you got two F's, it's false. The disjunction, it's only false if both are false, because as long as you got one or the other or both, it's true. The conditional statement is the weird one, because like I said, it depends on order, and that's what they're explaining to you up there. So, oh, that's the biconditional. What happened to the conditional? Right there. True, false, true, true. The only one that's false is when P or the first statement is true and the second one is false. It's false because that conditional makes the promise that if this is true, then this happens. So if it doesn't, it's false. And if you have a hard time wrapping your head around it, they give you this little exercise here. And then the biconditional is just the one that I had said is if they're the same, it's true. See that? Two truths is true and two falses is also true. But if they're mixed, true, false, or false, true, they're both false. So we got to know these basic ones, and there they got them again. That actually looks better than mine. All right. But you can also use that as a summary. Like I said, yes, while you're doing these, when you're doing the homework, when you're working on that review, have those to the side of you, because you're going to be able to learn them that way, because there's no way around knowing these five and realizing that they are all different. Let's see if we can create a truth table now. All right. P or not Q. All right. So what we got to do here is we got to have like a little table. Let's see if they got any tables in here. No. I'm going to have to create one. Nope. No, that's too big. All right, I'll just draw it on here with a regular drawing thing. All right, so with two statements, you got you're going to have 4 rows. And then the way we set these up, so this would be P, and this is Q. And so this is just a standard way of setting them up. You'll notice that those ones in the book that I showed you, they have 2 trues and 2 falses for the P's. And then the Q has true, false, true, false. And if you follow that pattern, you'll get the 4 that you need. You got true, 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 false, false, true, and false, false. Now, as I said, with set operations and the same thing with the truth tables, we need to go to the most complicated thing inside and then work our way out. And the most complicated thing is the not Q. So the not Q is just going to be the true column turned around. So true becomes false. False becomes true. True becomes false. False becomes true. All right. Now we're going to use this line. I'm sorry, this column and this column. We're no longer looking at that one. And so once we put these two together, this is done. All right. So we're using or. And remember, we got to. So or is this one. So it's true as long as there's one true. If there's 2 F's, then it's false. So there's 1 T, so it's true. There's 2 true, so it's true. Here's false, false, so that one's false. But we got a false true, which is also true. So using the or, there is the truth table for that statement. We can tell at any given glance. So in other words, if P is true and Q is true, then this is a true statement. If P is true and Q is false, this is a true statement. But if P is false and Q is true, then this is false. And same thing, if they're both false, it's true. So we can tell all 4 of the outcomes that happen with each of those given scenarios. All right, let's see if we can do find us another truth table to do. I probably got everything I need over here. I don't necessarily need the book, but let's try this one. All right, so the bad thing was you got to start a new one. I was hoping to use these little boards to actually do it on the board here, but all right, what was the other one? It was, but they don't have all this or all the symbols. Google took away my Freeboard. I was using, they call it Jamboard, and it went away. So it was P or Q and not P. P or Q and not P. All right. So again, we got to have a little drawing. And if you, what I would suggest is if you draw out one of these and then make some copies of it then on your paper, because this part is always going to be the same, the first three parts. In other words, I want to do some black. Let's do black. See, this part over here will always be the same if you just got two statements. Two truths, two falses. True, false, true, false. And if we do that for a two statement Venn diagram, we will have that part will always be the same. Now, what we want to build for is this whole thing. So I'm going to go inside out, left to right, just like plain old mathematics. So that means then right here on that one, I'm going to do that one first. All right. So that's just the basic one. That's just this one verbatim. So that's what we're getting it from. So there's been no other changes to any of them. So it's just true, 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 false. Because there's your two truths, so it's true. As long as you get one true, it's true. There's the one that's false. All right. So now we need to have a not P. So I'm going to put a not P here.
So, Mr. Cruz, if it's two falses, it's false and not true. So if you have two F's, it's false.
For the or, yes. For the
For the
or.
or. So for the and, if you have two F's, it's true.
No. For or, if you have two falses, both of them are false. That's the one case where they're both the same.
Okay.
All right. So or is two truths, true. One true, true. No truths, false. For the and, the only time it's true is if you got two truths. Otherwise, it's false. Because you're saying and, you got to have both. You got to be in the intersection. It's a more restrictive operation. The or just means as long as you got one or the other. The and means you got to have both. So the not P is just going to be the opposite. False, false, true, true. And then the final one is going to put these both together. So this is the whole thing. One step at a time. So now what I'm using now is the and now. See? I'm using and, so I gotta be thinking about this one, which is the and is only true if I got two truths. Otherwise, we'll put a false. So I'm looking at these two columns. I'm looking at this column and this column, and I'm putting together with and, following the and rule. So that's got an F, so that's F. That's got an F in it, so this is false. There's your two true, so this is true. Again, that's false because it's got one F. So there we got our final truth table that represents that statement. Okay. Hey, any questions about that? We're going to do a couple more, but.
Is it necessary to write just the P and just the Q columns? Like, I don't know. Does that serve anything for the equation?
Okay, I'm not sure if I get what you're asking.
All right, so the first two columns that you made, P and Q,
Mm-hmm.
like what if I just did the PVQ, not P, and then the
Well, you
final?
could, but you're going to have these in your head
Oh, okay.
because you want all four scenarios.
Okay. Gotcha.
So that's why you use this standard true, true for P, false, false, and then Q, true, false, false, true, false. Because see, that gives you four different ones. True, 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 false, false, true, false, false. It makes sure you're not replicating any of them. I'll
Okay.
just tell you that when I did this back in the olden days, I had that same question. And before I realized that there's a standard way of setting it up, I was trying to make sure I had all four of them, and it was a pain in the neck to do that. Now, that being said, if you're, like I said, if you're able to, you always want to have them in this order, and this is the drawback. So when answers get compared, if you don't have them in that order, that's where it comes into trouble.
Okay.
So that's just the standard part there, the first two columns, to make sure you have all of them, all of the four scenarios there. All right, so let's see. We can do a couple more. Let's do the ones with the and the the if and the only if. I'm sorry, the conditional statement. I might have to find one in the book. Might be better. I don't know if I have any good ones over here. All right. Yeah, I'll do that one. P if and only if, not P and Q. Okay, so that, oh, I got it backwards. Heck, it doesn't matter. I'm just going to do it. I don't want to run out of time. I want to get another big one in here, because you can have one with 3 statements. I doubt you'll see many, but I want to just, but that'll get it. It basically prepares you though for doing any kind if we can do the 3 ones. So here's going to be, I don't know how many I'll need. I'm just going to put like 4 or 5. All right, so this is P and Q. This is the same old thing. So true, follow that pattern and save yourself some grief, because just make sure you get all 4 of them. And then true, false, true, false. All right, so most complicated part, I'm going to do this, and I'm going to do the not Q, since that's the one I don't have. So not Q is just the opposite. So the opposite of true is false. The opposite of false is true. The opposite of true is false. The opposite of false is true. So I'm going to build here. I'm going to skip a line here, and I'll show you in a minute why. So that's P and not Q. This is right here. No, it doesn't look like it, but it's hard to get it. Like I said, I'm running on, I got about 15 minutes, so I want to get one more in here. So then what I'm doing is I'm looking at these 2 now, and I'm applying the and rule. So true and false is false. 2 trues for and is true. False, false for and is false. As long as we got 1 false for F, and it's false. So that's this one. I'm going to put the P over here again, so I don't have to read over those other columns. And then finally, the whole thing is going to go right in here, because now we're going to put together those 2. So I'm putting together these 2, this one and that one. And I'm using the if and only if. So in other words, if they are the same, it's going to be true. So true and false is false because they're not the same. True and true is true because they are the same. False and false is true because they are the same. Another mismatched one is false. So then this is the truth table for the whole thing. All right. I'm going to do one more. And if you got any questions on these, when you run into trouble, bring tomorrow the morning time, okay, in the night, at 11 o'clock. Bring any questions. I don't mind working through any of these, all right, to help you. All right, so let's find one more. Oh no, it closed up the. All right, I think I got one in here that's. Yeah, this is a 3-part one. All right. All right, what was in the middle there? So it's an and. All right, so forgive me if I'm going fast because I know I want to get this in it. It's just rather tedious to explain it and do it. So we're gonna make it a little bit longer, but now we're gonna have 3 of them. All right. So this is going to be P, Q, Q, R. All right. So I'm just going to do these left to right. So the first one will be P, Q. Now that's just the base. Okay. Oh, and I'm going to show you. Okay. So what you got to do is you're going to have 8 rows because we've got P, Q, and R now, and it follows the same pattern as the number of subsets, that 2 to the n thing. So if we have just one row, one statement, it's going to be 2 rows, like for the negation. If we got 2 statements, then it's going to be 4. And if we got 3 statements, P, Q, and R is going to be 8. But you do the same thing. You're going to go half and half. Half truths, half falses. So now this is going to be half. So every 2 we're going to change. So this one is true, true, and then false, false. And like I said, if you follow this pattern, you get all of them automatically. It's very hard to make sure you get all of these any other way unless you got a standard way of doing it. And this is just the standard way of doing it. So half truths, half falses. Now 2 truths, 2 falses, 2 truths, 2 falses, all the way down. And then this one is just like the other one. It's true, false, all the way down. And believe it or not, that gives us all 8 unique ones. See, they're all unique. All right. So what I'm doing then, I'm just using now the standard conditional. See that? If P then Q. So I'm using the first two. So two. The only one that's not going to be true is the one that's TF, and there it is right there. And there's two of them in a row. False true is true. False true is true, and false false is true. All right. Second one. All right. So this is Q and R. So now we're looking at these two. So true, true. Okay, let me write it up there. Q. All right. So Q and R. So we're doing the same thing. It's still the conditional. So true. This one's false. See that? True, false. This one's true. 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 There's another bad one. The other ones are true. All right. So what I'm going to do is I'm going to take these two real quick. And those are going to be put right here. The first two. I'm going to AND them together. So that's both of these put together. So we're using AND now on these. So true, true is true. As long as we got one false in there, it's false. So most of these are going to be false. There's another two truths. All the rest of them. Oop. False. And these two are true. All right. So that's the whole left side. Lastly, I'm going to do P, or the second to last step. Now I'm skipping that middle one. So we can kind of block that out for the time being. Don't get the wrong one. So now we're still using the conditional statement. So as long as it's not TF, so that's true. There's the false one. True. There's another false one. False true is true. False false is true. False true is true. And false false is true. And then we're going to put them all together, the whole thing. I'm going to put together this one and this one. So this is the last one is the whole thing. I'm using now the conditional, all right? So I'm using this rule right here. See, with here, I was using the AND. This is the conditional. So follow the conditional rule. True, true is true. False, false is true. False, true is true. False is true. Make sure I get them lined up right. True is true. False true is true. True. Sorry about the not lining up. So here is your final truth table for the whole statement. The whole statement. This is what we call all T's means this is called a tautology. And then tomorrow we'll see it when we finish up. If we have something that is a tautology, it's a valid argument. This is actually an argument because this right here is your antecedent. The whole thing here, this whole left-hand side is your antecedent, and then this is your consequent. But that's what we call a tautology. It's true. So this would be a valid argument. All right. If you got any questions, stick around. Otherwise, I'll see you tomorrow to finish up this chapter. Like I said, we're going quick. All right.
Thank you. Have a good day.
Okay. Bye-bye. All right. Thanks.
So for each symbol, you have different, like for the and symbol and the or symbol, the
Yeah.
if
See,
and the
again, that's why I had mentioned that about this thing.
yeah, I took a picture of that.
Yeah. They're all four different. The
Mhm.
negation is the opposite. The and, if both, the only time it's true is if both are true. You're always
Okay.
comparing two columns, one row at a time. If there's just one F in there, it spoils it. For the or, one T makes it true,
Mhm.
but true falses makes it false.
Mhm.
For the conditional, it's always true except for that pesky one right there.
Mhm.
That one right there. True, false. That's when that one is false. That's the only time it's false. If it's
Okay.
turned around false true, it's true. And then the biconditional is just if they match, it's true. Either two trues or two falses with the biconditional give us a true statement. But if they're mismatched, true, false, true, it's false.
Okay.
And like I said, the one thing you got to get across is all five of these are different. So you got to make sure you're using the right one at the correct time. You might notice one little thing that'll save you a little bit of headache is true is the only one that's true for all of them. All right.
Mhm.
So, like I said, is just make sure. And if you rather than memorize them, like I said, if you like me, I don't like memorizing stuff. That's why I just remember these statements, the four statements.
Okay. All righty. Thank you.
Okay, bye-bye.
Bye.
You okay, Chantel?
I am. Thank you, Professor Cruz. See you tomorrow.
Okay, bye-bye.